have B cell receptors which are called antibodies or immunoglobulins. First, immunoglobulin type M, IgM or immunoglobulin M is produced, but we have different classes of immunoglobulins including IgD, IgG, IgE, IgA, different classes of immunoglobulins. So M, D, G, E, A are different classes of immunoglobulins. So when classes of immunoglobulins are changed, there is a term called class switching. So the genes of immunoglobulins are recombined, changed, and have the ability to make other types of immunoglobulins, other classes of immunoglobulins. So if this receptor or antibody is of the IgM type, then it can change to other classes such as these, and these different classes of antibodies have different functions. For example, immunoglobulin G can pass the placenta, and immunoglobulin A is a mucosal type of immunoglobulin, or immunoglobulin E is important in allergies. So we have different classes of immunoglobulins, and this changing of to different classes is called class switching. So one of the actions that is made on antibodies is switching of classes for making new classes of antibodies. Another is affinity maturation. What does it mean? It means again changing in the recombination of genes to make immunoglobulins with a higher ability to bind antigens. So affinity maturation elevates the affinity or ability of an antigen, of an immunoglobulin for antigens. This is called affinity maturation. So these new terms with different meanings occur in antibodies of B cells for having specific functions and more ability to antigens. Class switching for making new classes of immunoglobulins and increasing the ability or affinity of immunoglobulins to antigens, which is called affinity maturation. One is this concept that I should have told you. I talked to you about CD4 and CD8 markers on T cells. T cell receptors composed of alpha and beta proteins and also some other proteins that help them. Presence of CD4 or CD8, which is called co-receptor. So if this is T cell receptor, this CD4 or CD8 will be co-receptor. And these proteins are MHC molecules, which can be of class 1 or class 2. So we have two classes of MHC molecules MHC or HLA, major histocompatibility complex. We have class 1 and class 2. These are special molecules that they can bind antigens and bring them to T cells. MHC1 and MHC2. Again, these are composed of some different types of proteins. This MHC class 1 is composed of alpha 1, alpha 2, alpha 3, and beta 2 microglobulin proteins. And two MHC is composed of alpha and beta proteins. So they have different structures. Antigens is bound here. So we have two classes of MHC for presenting the antigen to the T cells, class 1 and class 2. And something else, that class 1 MHC molecules, they bring antigens to CD8 plus T cells, and class 2 MHC molecules bring antigen to CD4 plus T cells. So CD4 and CD8 markers are co-receptors. So CD4 and CD8 molecules are co-receptors. Class 1 MHC molecule brings antigens to CD8 and class 2 to CD4 plus T cells. So this is another concept to learn. MHC molecules or major histocompatibility complex of class 1 and class 2. That class 2 is composed of alpha chain and beta chain, and it presents antigen to those T cells that are positive for CD4 as a co-receptor. And something else, that signals of activation of T cells by these antigens is composed of two signals. Signal 1 is activation of T cell receptor with the help of co-receptor. So binding of antigen to MHC and presenting of this antigen by MHC to a T cell, which could be CD4 or CD8 positive depending on the class of MHC. This is signal 1. Signal 2, for activation of T cell, both of these signals should be activated. Signal 2 again is composed of a protein on T cell and a protein on antigen presenting cell. CD28 is the protein present on T cell for making the second signal, and CD80 or 86 on the antigen presenter on the phagocyte or dendritic cell. So we learned that we have two signals for having an immune response. Only activation of a T cell receptor is not enough for having an immune response. The second signal, with the help of these new proteins, is also important for having a complete immune response. So it's composed of two signals. This is another concept in activation of T cells. The last thing that I will explain today is the types of T cells that I told you. Just the table, some characteristics of helper T cells. T cells, this is T lymphocyte, B lymphocyte, dendritic cell, natural. I should find it. Oh, it's at previous pages. So these were those pattern recognition receptors, 4 types. In innate immunity, then adaptive immunity, cellular immune system, humoral immune system, B lymphocytes, different types of T lymphocytes, helpers, cytotoxic and regulatory. Tissues of the immune system, primary and secondary.
MHC class 1 and class 2 cytokines. This table. This table shows helper T cells, T helper 1, T helper 2, and T helper 17. So the first row shows major cytokines that are produced by different T helper cells. T helper 1 cells, they produce interferon gamma. T helper 2 cells produce interleukin 4 and 5. 5 is special for eosinophils. And T helper 17, especially T helper interleukin 17. And the third is also important, that shows what is their duty, immunological reactions by different T helper cells. T helper 1 cells cause macrophage activation and stimulation of IgG antibody production. So T helper 1 cells, they produce interferon gamma, and by this they can activate macrophages and stimulate production of antibody of the IgG type. T helper 2 cells, they produce interleukin 4 and 5, and they stimulate production of IgE type of antibody, which is important in allergies. And they activate the cells that are important in allergies, including mast cells and eosinophils. T helper 17 type, they cause recruitment or accumulation of neutrophils and monocytes. Neutrophils are important in acute inflammation. So T helper 17 cells, they cause activation of neutrophils and monocytes. And what is this fourth row is also important, host defense against. T helper 1 cells are against intracellular microbes, such as viruses. Viruses are intracellular microbes that they need a cell to proliferate, to live. So T helper 1 cells are important for intracellular microbes. T helper 2 cells are important against parasites, so helminths, such as worms. So T helper 2 cells, that they are activated in allergies, and we have proliferation of eosinophils here. They are important in defense against parasites. And interleukin 17 is important in host defense against extracellular bacteria and fungi. They activate neutrophils and monocytes, and they are important in defense against extracellular bacteria and fungi. These characteristics are important in the differentiation between T helper 1, 2, and 17 types. So type 1 is for intracellular, type 17 is for extracellular and fungi, and type 2 important in defense against parasites. And rolling disease, so T helper 2 is important in allergies. As we said, it stimulates production of IgE, so its role is in allergies. T helper 1 and T helper 17 their role is in chronic inflammatory diseases and autoimmune diseases. So this table is important for differentiation between different types of helper T cells. So have a look at this table. It's important. It's an interesting table. So today we finish